Hi, today we are going to talk about tips and tricks for floor truss installation. My name is Chad Johnson. I have been in the truss industry since 1990 and I'm excited to talk to you about today's topic. What should you do before you receive your trusses? Well, the first thing is that you want to verify that the truss placement diagram and the truss drawings match with your plans or blueprints and the site conditions. It is not common, but occasionally either there will be a change to the building on site, or the truss designer may have misread something, and so there can be a discrepancy. It's much easier to catch that while we're still working with paper and pictures in a computer than it is once we have the product on site. Before you receive your truss delivery, you'll want to confirm that you have adequate space and material on site to take the trusses. The truss delivery equipment is oftentimes some of the largest equipment that shows up on the job site. It might be a tractor and trailer combination with a boom truck on it, and that requires a minimum of a 24-foot by 24-foot level and sturdy spot for the truck to set up for offloading. And additionally, you'll need space either on the building or on the ground or a firm surface to receive those trusses. Our preference is to show up with the material right when you need it, and that way we can set the floor trusses on the building very close to where they're going to go and minimize the amount of handling that's necessary. But in the event that we're delivering sooner than you're ready for them, they'll want to be stored on, we call it dunnage or stickers, some sort of material that keeps the trusses flat and keeps them up off of the ground and protects them from the elements that way. So now that you have your trusses on site, you'll want to check some things before you start the installation. First off, you should receive a material list with the delivery, and you'll want to go through that list and make sure that all of the items that are on that list are accounted for in the package that you have. The trusses themselves should be labeled uniquely to match the layout that you have, and the hardware that might be necessary for the truss installation should be on site if it was on that list. Also, before you start installation, one last check of the truss spacing and loading to make sure that it matches the plan is a good idea, and that can be found on the truss design drawing. Floor truss systems or any floor joist system could potentially have a different spacing called out on it. So common spacings are 12 inch on center, 16 inches on center, 19.2 inches on center, or 24 inches on center. That's referring to the dimension from the center of one truss to the center of another truss. And so when we talk about 12 inches on center, that would be 12 inches from the center of one truss to the center of another truss. Like I said, 12 inches, 16 inches, 19.2 inches, and 24 inches on center are all very common spacings. The reason that we use those spacings is because it works out well with regularly available sheet goods for the subfloor, specifically 8-foot long sheets. So 8 feet is easily divisible by 12 inches or 1 foot, 16 inches, 19.2 inches, and 24 inches with very little cutting or waste of that subfloor material. So the spacing, the center to center spacing, is typically laid out on your plans, but it'll also be on the truss placement diagram and it'll be on the truss design drawing. And so the truss design drawing will describe how far apart or how far center to center the trusses can be set, and they are designed to adequately support the loads. The truss placement diagram will illustrate for each portion of the building what the intended spacing was for that portion. And then the plans usually have an engineer's review, and the engineer will typically specify that spacing. So before we get into the installation, we want to verify that the spacing is known and aligns with the expectations. Floor trusses are installed using common framing tools such as hammers, nail guns, not too much in the way of a saw. If you're moving large bundles of trusses, a forklift or a boom truck is very useful. If you're moving individual trusses, they can usually be moved by hand. One or two people can usually move those. One of the benefits of using floor trusses is because they have a 3.5-inch wide flange. So the flange is the top and bottom of the truss, and that would look something like that with a bunch of webs in between it. So that top of the truss is 3.5 inches wide, as is the bottom. And so what that means is that it's very easy to move trusses to where they go and then just set them there. And they will typically stand up on their own without supporting additional weight, but for layout, it makes it very simple. So let's talk about the actual installation of the floor trusses. Now we're really getting into it. So as mentioned earlier, you'll receive a placement diagram. Let's just start with the absolute simplest, a square or rectangular building. So that installation diagram will show the individual members on it. So these lines here are representing the joists. The bold black lines on the outside might be representing your foundation or the walls that the joists are going to sit on. But these trusses are going to be placed at some sort of spacing that is defined on the placement diagram and the truss design drawing and the blueprints. And so we want to make sure that our trusses are laid out at the specific spacing and starting from the correct point. So when we're talking about a building that is an even dimension without any plumbing drops or interior walls or anything like that that would cause the need for special layout, it might be a little bit less important. But if we have an odd size building or an odd shaped building or any sort of plumbing drops or anything like that, the layout becomes very important. So just starting with this building here, let's say that the trusses are designed to lay out at 24 inches on center all the way across, just real simple. So we'll want to lay out the trusses at the specified spacing. Let's say that this is our double top plate here, and so we're going to start with our first truss on the outside, and this is essentially going to be at 0. Now for this first layout, we're going to deviate a little bit from that terminology of 24 inches on center, because we're going to go from the outside of the truss to the center of the first truss, 24 inches. And from that point on, it's going to be 24 inches to the center of each truss. And what that will allow us to do is when we put our sheathing on the floor, it's going to go 2 feet to the center, 4 feet to the center, 6 feet to the center, and then when we get to the truss that's at 8 feet, we're going to hit the center of that, and our 8-foot long sheet of material is going to stop at that center there, and then we're going to have another one start, and that way we don't have the material fall to the side of a joist. So whether we're doing 24-inch on center layout or 19.2 or 16-inch or 12, we want to do our first layout to the center of the joist, and then from the outside to center, and then it's center to center going on from that point. As mentioned earlier, there are instances where the layout might not be quite as straightforward, or it might be more critical that it be specific. So let's take our earlier nice rectangle building here and let's change it up a little bit. And let's say that this dimension here is 23 feet and this dimension here is 13 feet. So overall, we have a 36-foot long building. I'll put those marks down here where you might be able to see them a little bit easier. Well, because we are at a 24-inch on center layout and we have an odd dimension, we're going to end up with a truss that is just a foot off of this point and then a truss that is a foot off of this point. So let's say that there is a bathroom somewhere over here, and so we have a toilet that has a plumbing drop that is landing right in between two of those trusses at that 24-inch on center layout. Well, we know that we're supposed to lay out for here, but what if we started our layout from this end instead? Well, that would set all of the trusses 1 foot off of what was anticipated by the truss technician, and then look at that, we end up with a truss right in the middle of that plumbing drop, which is a bit of a hassle. It means either we have to adjust how that bathroom is laid out, or we're going to be doing truss repairs. Because we thought of it ahead of time, we know that that 24-inch on center layout isn't going to interfere with that. Now, occasionally, we may end up with a plumbing drop that just happens to be, this layout 24-inch on center from this end is the most efficient way to do it. And lo and behold, we've got a plumbing drop that's going to land right in the middle of a truss. Well, that's no big deal, because as long as we know about it ahead of time, we can just supply an additional truss and we can put one on each side of that plumbing drop off center. So it's a piece of cake as long as we know about it ahead of time. There are other situations that require a special layout as well, many more than we're going to talk about in this video. They should be detailed clearly on the truss placement diagram that you receive, but one common alignment is, or one common spacing is when we have a truss that is aligning with a wall. So for many different reasons, the designer or the engineer may call out that we need to have a truss in alignment with the wall. When that's the case, you'll see a truss that doesn't match the layout of the rest of the trusses, and so it's important that that truss end up there and not in a different spot. Usually they're supporting a wall above, or it's transferring load through the floor system as a result, or a calculated load that's for earthquake resistance or wind resistance. But those special placements will be called out on your truss placement diagram. So we've been talking about truss installation and layout from the standpoint of how it goes on spacing, but let's take a look at the other part of the truss where it's actually aligned, where the end of the truss matches up with the wall. So we're going to take off this bit here, and now let's go to a wall that has trusses perpendicular to it. So here's our outside wall, and this is our truss end. So we do the best we can to build every truss perfect. The reality is we're working with wood that is not always uniform. We're working with people who have great days and good days. And so every effort that we put into making the end of the truss perfectly vertical and the span of the truss exactly what the drawings call for, sometimes stuff ends up just a little bit off. Now, if you are working with a solid sawn floor system or a I-joist floor system, you would need to cut every truss or every joist. That's very unlikely to be something that you're going to encounter with floor trusses, but experts have told me that it's a good idea to align the outside of your wall with whatever is the outermost portion of the truss. So that way, if something is a little crooked, you don't have part of that truss extending beyond the outside of your wall. So just kind of an expert tip there to keep track of. So let's talk about floor truss orientation. As you can imagine, looking at this rectangle here as it sits, it kind of looks like it doesn't matter which end faces which way, or top or bottom, but indeed, it is very important. So I'll exaggerate a little bit here. When we build a floor truss, we build into it what is called camber. It's sort of like an arch being built into that truss. And the reason that we do that is because as we put our flooring on, as we put our ceiling on, as we put furniture and other loads on that truss, it's going to deflect a little bit. So there's a dead load deflection that we're going to build into that truss so that when it is loaded up, it ends up being flat. Well, as you can imagine, that means that there is a top to the truss and there is a bottom. And if we put that truss in upside down, that's going to cause some real troubles. Not only aesthetically and for the usability, but also from an engineering standpoint, the truss is designed to receive forces in one direction and transmit them out to the bearings. If we put that truss in upside down, the lumber grades, the plate sizes, the webbing patterns may not be adequate to support the loads. So we need to make sure that the top is on top. That's first off. Second, does it matter what right and left is? Sometimes yes, sometimes no. So most truss placement diagrams will have some sort of mark on them. Here at Truss Components, we have a triangle in the end of the truss on the truss placement diagram, and that indicates the left side of the truss as you're looking at the truss placement diagram. And so we would want to make sure that this end with the triangle aligns with the sheet of paper as we look at it on the left end. Well, why would that be important? Maybe you're spanning across a garage and there's nothing inside there, nothing special above it, it's just a bonus room. And in that case, right or left doesn't matter a whole lot. But let's say that this is a long truss that not only has bearing points at the end, but it also has a bearing point somewhere in the center of the truss. Or not in the center, but off the center. Let's say that it is a 36-foot long truss and we have a bearing point 12 feet in. So now this truss is going to have special accommodation for that bearing point to make sure that the loads are transferred from the top down to that bearing. And since we have 24 feet on one side of that bearing and 12 on the other, both sides are not going to be symmetrical. And so if that truss is turned around, that could put this bearing accommodation out in the middle of open space, and then that truss isn't going to be designed for transferring the loads properly in that condition. So if this is the left end of the truss on the picture, we want to make sure that that's also the left end of the truss on the placement diagram. Another condition that can occur on the trusses is we design into them often what we call a ribbon notch, and that's usually only on the outside end of the truss. And so if that truss is put in backwards and the ribbon notch goes on the inside instead of the outside, then it may be difficult to tie the ends of the trusses together at the outside bearing. How does an installer properly brace trusses during installation? That's a great question, and this is one of the areas where people can get tripped up. In a truss package, we have what we call strong back bracing. So here again is our simple rectangle. Let's say that that rectangle is 30 feet deep. So that would be the length of our trusses. The recommendation by the Structural Building Components Association is that there be what we call a strong back brace every 10 feet maximum along the span of a truss. Okay, well, what is a strong back brace and what does it do? If we are looking at the side of a floor truss and it has some verticals and some webs like that, let's say, That strong back brace is going to be a 2x6 that is going to be fastened to an upright member in that truss. Now it can go on the top or it can go on the bottom. That part isn't critical, but the critical part is that along that run of trusses, that strong back brace continues through and it ties all of those trusses together. And it performs two functions. One is it helps the trusses be more solid so that they don't topple. So it's an anti-toppling. But additionally, it ties all of those trusses together and causes them to work as a system. With a typical solid sawn or I-joist package, each joist is working independently. If you think about walking across a floor, each step that you take is stepping on one of those joists and it's doing all of the work by itself. But with this strong back bracing properly installed, when you step on one truss, that strong back transfers the load out to the trusses adjacent to it, and so it works as a system. The load gets distributed very uniformly. So that strong back brace is a great tool to help that system work well together, but it can also be another area where we get tripped up. And here's why. If you think about these trusses being set up at 24 inches, let's stick with that spacing like we were talking about before. 24 inches from one truss to the next. Well, we want to put these strong backs in the longest possible pieces that we can. Well, what happens if we get all of those trusses laid out and then decide to put the bracing in later? Well, it's not a big deal if we're building on top of a framed system and we don't put our sheathing on the end trusses until after we get those braces put in there. But one of the advantages of floor trusses is they work great in a basement situation in order to get all of your plumbing and mechanical, your heating and cooling up in those trusses. Well, in that case, you could have a foundation wall at the outside with a sill plate on it that is all the way up against the floor, and then your trusses are hung from the opposite foundation walls. And so now if we want to try and get that strong back in there, we would have to somehow get it through that concrete wall at the end, because it's nearly impossible to get long pieces of material up into that floor system after it's installed. So first trick to bracing your floor system is put your bundles out close to where they're going to go. So this might be a bundle of trusses here, maybe there's another bundle of trusses here, and those are going to be spread out 3 or 4 at a time. And before we spread them, we're going to put some pieces of material up there for the strong back braces. We'll call this preloading the bracing into the trusses. And that way, as we spread those trusses out, the bracing is already in there and we can just shift it to where it needs to go and attach it to the trusses. So that's tip number 1, is make sure that you get that strong back bracing up in your bundles of trusses before you spread them out. Some other things that we'll want to do before we begin our truss layout, or rolling out the trusses is how it's referred to, is we'll want to mark that layout that we were talking about on the framing surface. So an X and a line often shows that here's where a truss is going to go, and it's going to go on the X side of that line. So on our wall, we'll want to lay out those trusses ahead of time. And then it's also a good idea on that strong back bracing to mark your layout on that. That way, at the outside of the building, we have our trusses laid out properly. And then as we get to the inside of the building, we can also make sure that our centers are in alignment. Now, You do have that big 3.5-inch nailing surface on the top of the truss, that top flange like we talked about, but it's easier to get that flooring nailed down if we're on a good consistent layout all the way through the building. And so if we pre-mark our strong back bracing with that layout, we can ensure that these trusses stay nice and straight across the depth of that building. As we're spreading the trusses, it's recommended that you spread 3 or 4 trusses at a time and then fasten them to the structure to prevent them from toppling. So how do we fasten the trusses to the structure? It depends. There are a lot of different bearing conditions, but let's talk about a couple of them. So the simplest, most common, and best is what we call the ribbon notch at the end. And so in that case, you'll have your exterior wall. Your truss will be sitting on that wall, and it will be notched at the top for that 2x4 ribbon. So in that case, a couple of nails to secure it to the bearing, and then that 2x4 installed into that notch and nailed into the end of the truss. Those will work to prevent the truss from toppling as we move our way down. If you have intermediate walls, let's say we have a non-bearing wall in the center of the building, somewhere along the span of that truss, we want to make sure that the truss actually has the ability to move a little bit based on the loads that are being applied. And so in that case, they have what are called sliding truss clips. So those allow you to fasten it to the top of the wall, which keeps the truss in alignment this way, keeps the wall in alignment this way, but it allows the truss to move a little bit. There are some other products for that as well, but those are a few of the ways that we would fasten. Now, occasionally we have a different bearing condition, such as a top cord bearing, and that would be a double top cord over, maybe it's a beam, maybe it's another girder truss, could be a basement wall, but the truss itself is this portion here, and then a couple of nails into that beam will keep that truss in place. A nail from the bottom into that beam also can help keep it aligned well. So that's a top cord bearing. We have potentially a hanger bearing. So that could be the hanger on a beam, and the truss is going to sit in that hanger. In that case, you're going to install the hanger most likely before the truss is installed, and so that hanger will keep the truss in place. Another option is what we call a leg down, or a bearing notch, and that will look something more like this, where there's a bearing that is mid-height on that truss, and so there will be some members coming down to the height of that bearing. And so much like the hanger or the top cord bearing, a couple of nails into that beam and in the bottom will help keep that truss secure and prevent it from toppling. So let's dive into the order of operations. We've talked about some individual specifics, but we want to make sure that we do this stuff in the proper order for the best outcome. So first thing we're going to do, let's just say that we've got a set of walls that we're receiving trusses on, is we're going to get those trusses stacked in bundles close to where they're going to be laid out. Next, we're going to preload those bundles with our strong back material that has the layout marked on it. We already will have done our layout on the plate, typically before we even receive the trusses. So we've got our layout in place. Now we're going to spread the trusses, so we'll move the trusses to exactly where they go. We'll do that 3 or 4 trusses at a time, and as we go, we're going to install that ribbon bracing that's at the end of the truss. That's the 2x4 that goes in the notch at the top. So we'll lay out 3 or 4 trusses, install that ribbon brace, we'll secure the trusses to their bearing surface, and we're gonna work our way through the building that way. As we go, we're not going to nail that strong back bracing into the trusses yet. We're gonna spread it out so that we have it where it needs to go, but we're not gonna nail it. Once all of our trusses are on layout, so we've got our trusses every 2 feet. That's the 24 inches on center is the example that we've been using. So once we've got all of our trusses at 24 inches on center, we've got our ribbon brace in the end here. And so those are secured that way. Then we're going to put our sheathing on the top. So usually 4x8 sheets, oftentimes staggered. That's an engineer's preference, but we're going to get these sheets on the tops of the trusses. We're going to get them affixed per the engineering. So once we've got all of the sheathing and the ribbon in place, then we're going to come back and we're going to install that strong back bracing from below, working from ladders. The reason that we're waiting until this time is these trusses are very secure. They're unlikely to topple. We've got nails into the bearing surfaces. We've got sheathing on the top. And additionally, the sheathing is going to help hold those trusses all nice and uniform. So that strong back bracing is going to be 2x6s that are going to go inside the truss system and be nailed to uprights in the trusses. Now, why do we want to do that from below and afterwards? Well, one is safety for sure. If we're working underneath the trusses on a ladder, that's much safer than working on unbraced trusses, standing on them. They could potentially topple, you could miss a step and step through. But in addition to that, let's say that the average person is 180 pounds working on these trusses. Well, as that 180-pound person stands on this truss that doesn't have any sheathing on it or any bracing, that truss is going to deflect down a little bit. We'll nail that strong back into these 2 spots here and this spot here. And what we just did is we just built that deflection into that truss, and we would end up with a truss system that looked something like that after we put the sheathing on, because here was that deflection that was built in, here was the truss at its normal height, so on and so forth. So we want to get our sheathing on and then do the bracing from ladders below. Some other resources that we have to help you out with your floor truss journey are everything you would want to know about floor trusses compared to conventional floor framing. And if you'd like to get a quote, you can click right here and go to trusscomponents.com. We'd love to talk to you.